Hello, we're the 6th team of Frederick University Cyprus. In this 10-minute video, we will introduce to you our smart ecological cultivation system. My name is Katerina, and I am responsible for the business and marketing plan. This is Theodore.
Hello, I am computer scientist and I am responsible for the software, Windows Phone application and backend.
And this is Peter.
Hi, I'm electrical engineer responsible for the power unit, circuitry and solar panel.
And Jason.
Hi, I'm a computer engineer. I'm the project manager. I'm responsible for the microcontroller software and the sensor network.
CX is built around the belief that promoting cultivation and agriculture can have a significant impact on people's quality of life, as well as the environment. However, agriculture and cultivation, in general, is expensive. It requires high operational costs, such as electricity, fuel, human costs, as well as input material costs, such as water and fertilizer. Moreover, it needs to deal with extreme weather that may damage the crops and produce unexpected costs. Finally, inefficient use of input materials by humans may cause over-irrigation, under-irrigation, over-fertilization, and etc. These result in damaging or killing the crops that both have negative impact on farmers' economical situation as well as on the environment. All those costs, in addition to the global economical crisis, make people moving out of farming with dramatic consequences such as increase on food prices, overpopulation of cities, both leading to poverty and environmental degradation. In order to solve this problem, we offer a solution, coined Smart Ecological Cultivation System. Let's have Jason demonstrate our system. Just notice that Theodore will use the application and his actions will be demonstrated on the right-hand side of the projector, and Peter's will live stream all the actions performed on the system on the left-hand side of the projector.
Okay. The whole system consists of 4 components. The first component is a power unit. It contains a 12-volt battery and a photovoltaic panel. The photovoltaic panel rotates according to the position of the sun for full optimization of battery charging. Next, we have the control unit. The control unit consists of 3 microcontrollers. The master microcontroller is connected to the server and executes the manual requests coming from the farmer's phone. Next, we have the resources. We have 3 tanks containing water, spray, and fertilizer. On the top of each tank, we installed ultrasonic sensor to provide us instantly the level of each tank. These tanks are connected to the pumps. The pumps are connected to the solenoid valves and target each field. The last component of our project are the fields with the sensors. We have installed an air humidity sensor, an air temperature sensor, and soil humidity sensor. And now my colleague will automatically water the open field. Next, we have the greenhouse. Greenhouses must have steady temperature and humidity. In order to provide this, we can open or close the windows. My colleague now will manually open the windows, as you can see at the right side of the projector. And if we want to cool it faster, we can turn on the fan. That was the manual mode of our application, and now we are going to move on to the automatic mode. As you can see, we provide a list of crops to the farmer, and he can select any one of these. And as you can see, the right side of the application, we provide some fixed values. These values are provided by the Agricultural Research Institute, and we store them in our Joule Cloud database. And with the sensors, with the values measured from the sensors in the field, and with our algorithm, decides automatically whether to spray, fertilize, or water. Moving on to the statistic page, these statistics are very important for the farmer. The first chart, as you can see, is the average consumption of the resources. Next, we have the daily temperature of the open field and the greenhouse. And then last, we have the humidity of both fields. Next, we have the live data. These are real-time data measured from the sensors in the field. They are categorized by the crop sensors, the greenhouse sensors, and the tanks level. Finally, the last section of our application is the live feed. This is very important for the farmer to keep track of his previous actions that he has done in the fields. And we provide this history log to remember and remind the farmer for these actions. Now, Katerina will continue to the marketing and business plan.
Thank you. Our vision is to provide a user-friendly, sustainable solution for cultivation that will motivate households, farmers, and other entities to promote green cities, provide better cultivation experience to people interested to engage in agriculture, gardening, etc., as well as reduce the aforementioned costs and protect the environment. Our product targets two general markets, the business to business and the business to consumer. The former includes people engaged in industrial farming, where the latter group includes suburban areas and people with small private fields on the backyard of their houses, plus urban areas and people with small gardens or growing bioproducts on their flat balcony. Our revenue model includes both the hardware and software parts of our system. For the hardware, we plan to sell a smart kit with minimum components that will have instructions that can be installed in a DIY manner. For the software, we are going to follow the freemium model and in-application purchases. For promoting our system to both B2B and B2C target groups, we are going to use several means like advertising online, billboards, magazines, newspapers, and radio, as well as social media and public relations through press release and relevant journals. Thank you, and we hope to see you in Seattle.